What's going on, everybody, and welcome to the Aimtec Academy. Before getting started, I just wanted to hope that you guys are staying home, staying safe, and washing your hands. Now, the idea behind the Aimtec Academy is Aimtec will actually be producing various modules on different Aimtec applications, and at the end of all of these modules, there will be a small quiz to actually test your understanding of the subject. Once the module is completed and the quiz is passed, Aimtec will actually issue a certificate stating that you guys passed the training module. And then, in this case, on Aimtec's EV charging solutions, you will be more equipped to sell Aimtec products to EV charger manufacturers. So now, without further ado, let's hop into our first lesson. So now let's begin our first training lesson on Aimtec EV charging solutions. We'll start off by looking at how EV chargers have actually evolved over time. So in the left graph, we have normal and fast charging stations across Europe. So in 2010, or actually in 2011, we had significantly less than 25,000. And in 2019, we're looking at almost touching 200,000 EV chargers across Europe. Now, on the other hand, we can also look at the vehicles that were actually on the road in Europe that don't use fossil fuels, or that don't use the conventional fossil fuels. So what actually interests us the most are BEVs, or battery electric vehicles, and PHEVs, which stand for plug-in hybrids. So the BEVs are in yellow and the PHEVs are in orange. As you can see, PHEVs have not been very popular in Europe and hardly any have been sold at all. But if we look at the BEVs sold in Europe, it's a much more interesting trend and we see the significant growth over time. We can also look at what we're actually projecting the EV charging stations to be in the future. So in 2030, this is what we're expecting to find in Europe. All the numbers that you see in the graph are in the thousands, but just as an example, Germany will be expected to have 720,000 EV chargers by 2030. Germany is a perfect example that shows how much EV charging stations will be important for the economy and for manufacturers in the future, because as we shift our mobility from fossil fuels to electric vehicles, we will need a rapid growth in charging infrastructures to support all these battery electric vehicles on the road. Now also, just for fun, we can look at how electric vehicles have been evolving in the news. I found 3 examples that sort of also illustrate how electric vehicle charging stations will be important for the future. So, for example, India will be adding over 2,600 EV charging stations across the country over the next coming years. Furthermore, global EV charging markets are projected to grow at a CAGR of about almost 40%. So that's just saying that, well, every year, the growth in available charging stations should grow by about 38.8%. Finally, on another note, Turkey wants to produce its own EV, and it'd like to reach a number of 175,000 units produced over the next 13 years. And they're investing $3.7 billion on this domestic, homemade, full electric car. This is also very interesting because it shows how various countries across the globe are actually striving to increase either electric vehicle production or electric vehicle charging stations. Now, this is the end of our little introduction to electric vehicle charging. Now let's actually get into why you guys came here for. So how do Aimtec power supplies actually fit in this market? To start off, we'll look over some simple requirements for Aimtec modules, or actually any power supply module that you want to use in a charger. They need to be highly efficient to reduce the power consumption and the amount of heat produced while charging the vehicle. You also need to have a high reliability, so large MTBFs, to sort of decrease the amount of equipment failures, because once an electric vehicle charger is deployed, it's usually not serviced for a while. And servicing these chargers are inconvenient because, first off, you need to send a team out to actually service the charger, and secondly, while it's being serviced or while it's down, you are no longer able to charge your vehicle at that station. Since we're connecting to an AC power source, we need to have a minimum of 90 to 264 VAC input, and in some cases when we are connecting to a 3-phase power source directly, we'll need the 90 to 528 VAC input voltage range. Finally, high isolation between circuits are important because of the high voltages used. Now quickly, this is an overview of the different charging stations available across Europe. So we're going to be looking at mode 2, which is an AC charger box or a portable AC charger. In this case, the box is actually attached to the wall, but you can also have a simple portable AC charger that you plug into the wall, and the actual box that is attached in the wall in this picture is portable. For those following this tutorial in North America, this would be a level 1 charger, which connects directly to a 120 volt outlet or socket in the wall. Mode 3 for Europe is going to be called an AC charging station. This connects directly to the grid and supplies the car with AC power. Then the onboard converter in the car, or the onboard charger in the car, converts the power from AC to DC and then charges the battery. In North America, this would be called a level 2 charging station. Finally, the Mode 4 charging station is a DC fast charger. This does not use the onboard charger of the car, it directly bypasses it and supplies DC current directly to the battery. In North America, this would be called a level 3 charger. So now let's look at the AC charging box, or the portable AC charger. So as you can see based on this block diagram, we have an AC input of 230 VAC entering the box. This 230 VAC goes through AC relays and contactors, and then through the current sensing, and then directly to the electric vehicle. Now Aimtec is not included in actually bringing the current or the power from the wall or the 230 VAC input to the vehicle. What our products do is we power the actual charger itself. So looking at LDOs, controllers, display units, and pilot signals. Based on the block diagram, our Aimtec AC-DC converters convert the AC current to DC. So we're looking at an 85 to 264 VAC input voltage range, and we're converting that to 12 volts. Now these 12 volts, as shown in the diagram, can actually power AC relays, contactors, and the LDO. At the same time, these 12 volts are then sent to our Aimtec switching regulators, or non-isolated DC-DC converters. And what this does is it gives the pilot signal the required negative 12 volts that it needs to work. So if we look at the pilot signal box, we see that it's getting a positive 12 volts from the AC-DC converters and a negative 12 volts from the Aimtec switching regulators. The reason why we actually use switching regulators in this case is because since the pilot signal does not require isolation, it's cheaper to use non-isolated switching regulators than to use isolated DC-DC converters. Just as a quick FYI, these are the different models that we outlined in the previous diagram. What's interesting to look at here are, I would say, the operating temperatures and then the dimensions of the various power converters. Depending on what your customer is looking for, some models may be superior than others if they're going to be operating in harsher climates or if the design space on their board is limited. Aimtec has actually recently released a new triple output AC-DC converter. So what this converter actually does is it can replace, if we look at the previous diagram, the two Aimtec boxes. Because what it does is it actually takes in the 230 VAC with an input voltage range of 85 to 305, which is what the AC-DC converter has. And then it's able to supply not only a 5 volt and a 12 volt output, but also a negative 12 volt output that is required by the pilot signal. Everything else remains the same, but one of our components can do the job of two, thanks to its triple output. So this not only saves cost and reduces the bill of materials, but it also saves a lot of design space. Now we're going to be moving on to the AC charging stations. So for the AC charging station, again, similar to the portable EV charger, Aimtec does not actually supply power to the car. What we do is we power all of the onboard equipment for that actual charger. So for AC charging stations, we may want to actually connect to the three-phase power source directly, so we will be requiring a 90 to 528 VAC input voltage range converter. In the block diagram, we see these represented by the AME20 and AME10 12S BJZ. The AC charging stations are more complicated chargers with more safety features, better user interface, and may also have a card or RFID reader. These greater features require more power, which is why we actually are using 30 to 60 watt isolated AC-DC converters in some instances. As you can see in the first box, we're going all the way from 10 watts up to 60 watts. Now, in the second box, Aimtec offers multiple 15 to 20 watt DC-DC converters that are great for a variety of devices within the circuits, such as current sensors, microcontrollers, and the HMI, or human machine interface. Again, here's a list of the actual converters that Here are some of the AC-DC converters and DC-DC converters that we were referencing in the previous example, Again, I would look at the operating temperature as well as the dimensions of the different converters depending on your customer's requirements. We'll now be moving on to the DC EV charging station. Now this charging station is what actually charges the vehicles in the fastest manner by directly bypassing the vehicle's onboard charger and supplying DC current directly to the battery. So in this case, the DC charging stations do not use pilot signals to communicate with the electric vehicles, thus eliminating the need for minus 12 volt converters. Instead, it relies on a more complicated CAN bus communication. Therefore, an additional isolated 5-volt DC-DC converter is used to ensure the quality of the CAN bus communication. So this is actually represented in the third box. We have models going from half a watt all the way up to 1 watt that actually will be supplying the power to the isolated CAN bus. The difference between these DC-DC converters and the switching regulators used in the first example is that they actually offer isolation, which is required by the CAN bus. Typical DC charging stations use a resonance circuit to bring the output voltage to the desired level, and is usually done by IGBTs. Aimtec's isolated dual asymmetrical IGBT drivers can be utilized to generate the required positive and negative voltages to drive the IGBTs while providing an extra layer of protection. So in this case, we're looking at the AM5TG and the AM2DG-NZ. Here are the few new models that we used in the DC block diagram. Again, feel free to look at the operating temperatures, the different isolations, and the case sizes. And now for the last block diagram, we're going to be looking at portable EV power banks. Now these are used to quickly charge electric cars that could have lost power on the road. So if you're driving along the highway and all of a sudden you lose power, there's a fault in your car, which then shows that your battery is actually fully depleted and you can no longer get anywhere, you can call roadside assistance and they can quickly come and fast charge your car with these portable EV power banks. So now there's two modules in this block diagram. There's a battery pack and then there's a level 3 or a DC fast charger. On the left we have the battery pack, and what our products actually do is they pretty much power the battery management system, or the BMS. There's also a CAN communication system that we can also power as well, as illustrated in this diagram. Since the battery management system needs to be able to work independently without other power sources, Aimtec's 100 to 1000 volt to 12 volt output isolated DC-DC converter can help power the device electronics, which operate at much lower voltages. So in this case, we're looking at the AM15W 612S-NZ. The charger module has an additional auxiliary battery to power its electronics and auxiliary circuits independently when the charger does not receive power from the high voltage battery. On the right side we have the level 3 fast charger, or the DC fast charger, and the circuit looks very similar to the one above. So this is a very new application where portable EV power banks are going to become more and more popular as there are more electric vehicles circulating on the road. This offers a great opportunity to expand your customer base. Well, this is the end of our first module on electric vehicle chargers. I hope this presentation helped you guys identify where the Aimtec components go within the different chargers, as well as what their different roles are depending on where they're placed within the circuits. Aimtec really sees electric vehicle charging as one of the next great steps for our power supply industry. With more vehicles on the roads, governments looking at expanding the electric vehicle charging infrastructure, as well as advances in technology such as our triple output AC-DC converter, Aimtec thinks that the future is very bright for electric vehicle chargers. I just wanted to thank you guys for tuning in, and good luck on the quiz. At the same time, stay home, stay safe, and wash your hands.